Well, nowadays we do use recommendation system very often for different tasks, and it's very important to make sure that we know what's going on with the quality of our recommender system, what is going on with the revenue. This is why today I'm going to share with you some thoughts on monitoring recommender systems in production. Basically, we do use recommendations like everywhere. Nowadays, we have a lot of content implemented in e-commerce systems like lots of products and services. And we have media systems where we have quite a lot of content for users, and recommendations helps our users to find quickly relevant content, right? And we do use recommender systems not only in media and e-commerce, but also for different products varying from procurement to manufacturing, where we use recommendations to help us find what is the next best action or what is the optimal strategy for procurement, right? This is why it's pretty well spread. So the question is how to evaluate recommendations. And basically, pretty often when we use recommender system, we optimize our business process or technological process one way or another, right? And this is why usually we can follow the money. Basically, for almost any recommender system and service which uses recommender system, we can calculate something like total revenue or average revenue per user. Maybe it's average check or something related to money. And the good news is that it's quite convenient and easy to measure the economic effect from our recommender system in the online experiments like A/B test. Why so? Because basically for online experiments, it's very easy to split our users or other objects into two groups, where in one group we do not have our recommender system, in the other group we do have recommender system, and if the recommender system is the only difference between A and B segment, we can easily compare the revenue and attribute the additional economic effect to our recommender system. So it's very convenient to measure the revenue in terms of short-term effect in A/B test. But it's not that straightforward in terms of long-term evaluations, right? Especially when we deployed our recommender system to production and later we want to see how much additional value, how much additional revenue we are able to generate with help of our recommender system. In this case, you have two main problems. First is attribution problem, right? Because when we already use our recommender system in production, it's really hard to assign the exact part of our revenue to recommender system, right? And for debugging issues, it's quite similar because let's say we see that our revenue dropped and it's revenue from the whole service, right? What exactly has happened? Is it happened because we have some data quality issue, or maybe it's because the quality of our recommendations get worse, or maybe it's just the market itself, right? So it's quite hard to debug and connect the quality of our recommendations to the revenue itself. This is why it's important to build the whole observability system to figure out what's going on with our service and be able to debug things faster. In terms of evaluating recommendations in production, I would like to present to you a recommendation metric hierarchy. I believe it's very important to build up such a system, especially if you have your recommender system already operating in production, because it helps to quickly observe what's going on and quickly react appropriately to any issues. So first of all, we start from the online business metrics. Generally, it's something connected to money, like revenue, average revenue per user, etc. Then you can go down to online quality metrics, and the trick here is that we need to find out some proxy metrics which are closely connected to our revenue metrics, but can be easily calculated in online, like clicks, views, friends invites, maybe conversion from one game level to the other for online games. It's very dependent on the problem statement, right? And finally, when we work with our recommender systems in offline, we can calculate quite a lot of quality metrics. It can be metrics related to the ranking quality, like recall at top K objects, precision at top K, mean average precision at top K, etc. And it can be many beyond accuracy metrics, like novelty, diversity, popularity bias, etc. Let's take a deeper look at those metrics. So first of all, online business metrics. This is always a priority, right? Because that's the KPI metrics for our service in most cases. These metrics help us reflect to the business impact the best way. Unfortunately, sometimes it might be quite hard to measure such metrics directly. Happens because, let's say, we work with the e-commerce application where our users can buy some products. In this case, we might show some recommendations, right? And it's very easy to measure like views or clicks to recommendations, but it's much harder to like measure the purchases because sometimes it took users like hours or days or our weeks to decide whether to buy something or not, especially if it's something quite expensive, right? So if, let's say, users need like several weeks to decide on the product and buy it, and if we already have our recommender system in production, we might just miss the moment when the quality of our recommender system started to really influence negatively to the revenue, right? And if, for example, user need like 2 weeks to, in average, of course, to commit a purchase, but after 1 week, the quality of our recommender system drop, we have no chances to detect it and react in time, right? This is why it's important not only have our online metrics, business metrics, but also have very good proxies to connect to business metrics. So anyway, we start from the correct online business metric, right? And in order to get a complete picture, we need to add more. So the next group is online quality metrics. Those metrics are often called proxy metrics because it's help us to detect some issues with the revenue-like metrics faster. Those metrics are very use case specific. Generally, it can vary from clicks, views on media content, purchases or added to the basket for e-commerce, or some conversions in gaming, maybe even some conversations lands, or maybe invitations to friends in a social network. So in order to be able to come up with the good proxy metrics, it's important to have some understanding and experience of the domain area. Basically, those are metrics which are very easy to calculate, especially in real time, because clicks shows it's something that we can measure like directly. This is the proxy symptom level monitoring metrics. And this is why we can easily set up some alerts on such metrics, like maybe alerts on the average share of clicks on recommendation block, or average share of conversion from a level n to level n+1 in online game, etc. It's very nice to also analyze the connection between the online business metrics and such metrics like correlation in order to be able to set up the right alert. And those metrics are also very nice for debugging because let's say if our revenue-based metrics like average revenue per user goes down, we can go and analyze clicks and views if we have those metrics already in our dashboard so that we can faster figure out what's going on. Also, there are a bunch of offline metrics which we generally use in offline during the model's evaluation process, specifically when we train new models, do some experiments, or maybe do candidate selection before the A/B test so that we promote to the A/B test the best option, the best metric, right? But the good news is that those metrics also can be used during the monitoring. The complication with those metrics is that generally we are able to calculate those metrics and use them properly when we calculate it on batch of the data, because when we calculate something like precision at K or recall at K for individual user, it doesn't really give us a lot of insights, right? So it's better to have a batch of users than calculate this precision at K or recall at K and then analyze the values. So it's hard to measure those metrics on top of individual users, but it's good to measure them on top of the batch of data. So why not to calculate it in a batch mode in online? Like, for instance, calculate those metrics every 10 minutes, every hour, on daily basis, or maybe once per week, right? It can be done perfectly. And actually, that's very nice, help us to with debugging, right? Because we can always connect our online metrics with those offline metrics calculated in batch and see what's going on. This helps us to connect the model quality itself, like quality of ranking, with some proxy metrics and online metrics. This is why it's very important to not only like monitor those metrics, but also make some additional analysis. I would say it's super important, especially if you automate the way of model retraining and candidate selection. I mean, if you do it automatically and you rely on your offline metric, it's essential to know how exactly those offline metrics connected to revenue-based metrics and proxy metrics. Because, well, if you do candidate selection on top of offline metric and you are not sure whether those offline metrics are like even correlated with online metrics, then what's the point, right? Our idea is to promote the model which is expected to be the better one during the A/B test, and this is why it's important to make sure we use the relevant offline metrics. So that's why I believe that's very important. And well, I would like to share what metrics can be used in offline mode because we do quite a lot. And here I would like to mention that I'm showing to you the examples of reports made by Evidently, open source library for model monitoring, testing, and validation. And I'm a maintainer, so I'm not insisting that Evidently is the only library you can use for recommender system quality estimation, but here I'm sure what we have. This is why I share it with you. So for recommender system, we have quite a lot of metrics like precision at K, recall at K, F-score, and those metrics can be calculated not only in a monitoring way where you have new evaluation for each new batch of data, but also you can compare the value of those metrics between the reference data, if you have them, and the current data, which is quite nice for debugging. Because if you have your reference data where you are happy with the performance of your recommender system, you can always compare the precision at K, for instance, between those two batches of data, and it's much easier to come up with the conclusion whether you are happy with the particular value of your metric or not, because you know what is your baseline, what is your basis for comparison. And well, there are quite a lot of such metrics. There are also metrics for ranking, like normalized discounted cumulative gain at K, mean reciprocal rank at K, hit rate, mean absolute, mean average precision, etc. And it's very nice to like first think through those metrics and select the right ones for you. Because for instance, if you build your recommendations and you know that there is one relevant, the most relevant object among your recommendations, you might want to go to the hit rate because you want to calculate how often you cover the most relevant object in your recommendations. But if you want to like have a lot of relevant objects in the right let's say in the right order, right, with the relevant ranks, then instead of hit rate, you might prefer to use normalized discounted cumulative gain. So it's always good to analyze and choose among the offline metrics and select the one which correlates with the revenue in a best way, right? Also, together with the quality-based metrics, there are quite a lot of beyond accuracy metrics like serendipity, novelty, diversity, coverage, and different biases. And it's also quite good metrics because if you understand how exactly your used recommender system in production, you can always find some correlation between those beyond accuracy metric and the revenue-based metrics, right? And evidently, we also have a lot of beyond accuracy metrics implemented, so you do not need to implement them, those metrics yourself. And well, we have diversity, which is basically show how varied are the recommendations shown to each user. And if you know that your users react best on diverse recommendations, where you have, for example, movie from different categories or products from different categories, it's good to measure this diversity even in a batch way in online and have this metric plotted on your dashboard, maybe in a separate tab compared to revenue-based metrics, because you will be able to quickly switch between those tabs and debug issues faster. So here is the diversity, novelty, how novel are the recommendations compared to what the user had in the training set, or compared to the previous interactions of the user. There is personalization, so we can measure the overlap between the different users' recommendation lists. It's also serendipity, so if you know that your user prefer to have some surprising recommendations and you don't want to recommend the second Harry Potter to the users who already saw the first Harry Potter, then serendipity is your metric to make sure you do not do that. There are also a lot of biases like price bias or popularity bias. And if you know, for instance, then if you start to recommend less expensive products, then your revenue goes down, then probably the price bias is something you want to monitor, as well as the popularity bias if it's the case for your system. I also want to make a short side note and talk a little bit about the debugging, because quite often if we see some quality drop in production, in terms of revenue, for instance, we start to dig deeper and analyze some proxy metric. Then we go to some clicks, views, purchases, and sometimes it's enough and it helps us to quickly figure out what's going on with our model, but sometimes it's not. And then you go to offline metric and, well, it's hard to find the reason of quality drop quickly. For being able to debug and perform ad hoc analysis quite fast, I suggest you always have some additional tools under your sleeve to item level or user level debugging, because it's very, very helpful. Let me show an example here. So imagine you work with some movie recommender system. In this case, you might create this let's say, avatar users who are not actual users, but you might create users with very particular properties. Like, for instance, you can create or simulate a user who always like to see, let's say, romantic movies, and the other user who prefer to see some horror movies, right? In this case, if you know this property of the user, you can generate like the synthetic history with these popular horror movies, for instance. And then you can create some expectations on how the ideal or good recommendations look for this synthetic user. In this case, if you have a tool which helps you to quickly observe what is the recommendations generated for a specific user, and evidently we have this specific metric, which is called reg case table, but it's not the topic here. Of course, you can later figure out. I have a picture from the left hand side, right? Then you can quickly observe what was recommended. In our case, the previous interactions were like Ice Storm movie, Mr. Brown movie, and like you can see, Titanic, As Good as It Gets, right? And in the table nearby, we can see the ranks and the movies we recommend. And if you see something weird here, for instance, for a user who had quite a lot of romantic comedies during the interactions in the previous history, you suddenly started to recommend a lot of horror movies, then it can help, such things can help you to quickly come up with good hypothesis of what's going on, right? This is why I believe we should not like hesitate to analyze even individual users or objects, because, well, of course, we cannot really apply the results to the whole generation, but it helps us to come up with good hypotheses. And even if you do not have this synthetic avatar users, you can go for some random users who have a lot of history, right? And analyze several of them so that you can get some insights. And pretty similar things you can do with the properties of the items or users. For instance, like in the pictures you can see from the right part of your screens, right? In this case, we have an item properties, which is called crime. So basically, this is the genre equal to crime, and we have the data from the reference and the current batch. Let's say reference, its recommendations from the yesterday, and current, its recommendations from today. So during the training period, we saw that we had 10% of recommendations where the genre was equal to movie. So we have crime equal to 1 on x-axis. And in 90% cases, we did not recommend a movie with the genre equal to crime, right? So in 90%, it's not crime. So, and we see that during the reference, during yesterday, we had like, it's almost, let's say, 17% of recommendations of crime movie, but today in the current, we have 0% of the crime movies. Maybe that's the good hint to go and dig deeper what's going on with our data processing pipelines, right? So maybe it's some pipelines, some issues of the data processing. So this is why I believe it's also very important to start thinking about how exactly you're going to do some ad hoc analysis and prepare some tool or infrastructure for doing that. Well, going back to the metrics in monitoring, we can kind of rank our metrics from the monitoring issues to the debugging issues. And if you focus more on monitoring and alerting, then you should be implementing primary business metrics and some online proxy metrics, right? But if you want to have like full-scale durability and focus also on debugging and analysis, it makes sense to add some offline metrics and analyze the connection between the offline metrics and online metrics. Why so? Again, it's very useful for future candidate selection, especially if you will be able to understand the nuances between the model behavior and the value of your KPI metrics so that you can optimize the process of selecting the best models for future experiments and production. Now, let me finally say a couple of words about full-scale machine learning observability and how it looks for recommender system particularly. Basically, previously we discussed two groups of metrics, even three groups of metrics for recommender systems. So we discussed business KPIs and we discussed online and offline proxy quality metrics, right? So this part is already covered. But if we take a look at the whole system where we use our recommender system model only as a part of the service, right? For instance, like an e-commerce where we have the full product, the full marketplace system, right? And the recommendations is just a part of it. We need to make sure that the whole system works. This is why, together with business KPI and model quality and relevance, we also need to implement software system health monitoring. I know that it's quite obvious, so it goes without saying, but I want to mention it specifically that, well, as soon as we promote any service to production, we need to make sure that it's properly monitored from the technical point of view, and metrics like disk usage, memory usage, response time, etc., are covered by alerts and automation system to react on those alerts. Also, when we have some services which relied on the data, it's important also monitor data quality and integrity, right? Because in most cases, if something is wrong with the data, it can ruin the whole model, right? And here I want to mention data quality and data drift specifically because if we build our recommender system on top of quite a lot of different data, like maybe product properties, maybe user item matrix, etc., then we need to make sure that all this data looks good, right? By looking good, I mean that we can measure quite a lot of input data properties, like some descriptive statistics, means, median, standard deviation, and check whether we have like expected values, whether we have some expected values for missing values for different features, right? Maybe some values for are out of range for specific features. So it's all very important. And we can also add some data drift metrics as well, especially if we are not sure that our model extrapolates really well, right? And if we assume that the shift in the distribution, especially for important features, might like really influence badly on the quality of our model, then it makes sense to add to data quality data drift monitoring as well. So it's kind of extra level which stays between the service health monitoring and model quality monitoring. Quite often, especially if you have pretty complex pipelines with a lot of steps which process different types of data coming from different data sources, it makes sense to monitor data quality because it helps you to catch data pipeline bugs faster and debug them appropriately. So finally, I would like to sum up what we just discussed here. And well, we started from the metrics which we can use for recommender system monitoring. And we discussed that it's quite important to define the straight hierarchy for our metrics. We always start from the revenue-based metrics because that's the main KPI for our service. And then we go to online quality metrics because sometimes it's quite hard to measure revenue straightforwardly, right? Online quality metrics is a very nice proxy. So if you know the connection between the online quality metrics and business metrics, we can get right alerts and detect issues faster. Also, it's quite a good idea to have some offline quality and beyond accuracy metric calculated in a batch mode on the same dashboard, because it will help us to debug things faster. And well, we also discussed that you work with production service, which is rely on the data. So make sure you keep an eye on your data quality and data drift. Make sure you implemented service health monitoring. And well, it's always have to put some additional tools under your sleeve in case that there is some issues, and it will help you to do some object level debugging and feature level debugging, because it always helps to detect issues faster. So that's all I wanted to share with you guys. And if you have some comments and questions, I'm happy to discuss.
Hi, Emily. Looks like we have a Q&A. one question in the Q&A.
Cool. Yes. So how did you historically tackle issues with business metrics for recommending system? Oh yeah, that's a very good question. Thank you for raising it up. Yes, the cannibalization, margin reduction, etc., is the very important problem, because let me just quickly comment so that everyone understand the point here. So quite often we face the issues when the recommender system itself influences the recommendations we have. Like we recommend something, then users react, and then we have those data in the next training data set, right? Or maybe if previously on our website we had only search for the products and users use this search to navigate and find and buy the relevant products. So now we added the recommendation block and we just cannibalized some traffic from the search to recommender system, and it's quite hard to detect that. And yes, to work with such issues, I suggest to collect relevant online metrics like revenue and etc., and then use your service logs to calculate different offline metrics and then analyze the correlations and different kinds of connections between those metrics. Evidently can help with that, because we have a large variety of offline metrics and a lot of options how to like parameterize the metrics calculations. It partially solves that, because you will be able to like analyze the connection between your online metrics and this offline metrics, so that you can analyze and do candidate selection better. But unfortunately, it doesn't cover like 100% of the issues, because, well, the way recommender system influences the new data can be solved like in offline, right? For doing that, I recommend maybe have like at least some users. Well, sometimes it's quite hard because, well, it's hard to like not show in recommendations to the significant bunch of users, but sometimes you can do that. Maybe have very small amount of users who from time to time does not receive any recommendations, so that you can keep tracking them and calculate metrics on top of those users, so that you can compare and have like clean data feed. And maybe you can use multi-arm bandits, which provide some users from time to time with like very, very small probability with like random recommendations. Of course, it's always depends on the problem statement, and it's not like a general advice, nothing like this. But if your system allows you to do that, you can use multi-arm bandit system to like sometimes with some probability recommend the random products for your user, and by doing that, get rid of the influence of your current recommender system and calculate some metrics on top of those like recommendations without any influence.